Hello and welcome to the Valentine's Day edition of Cracking the Cryptic, and happy Valentine's Day to you all. I hope you have been inundated with cards and roses and chocolate cake especially. And well, I'm getting a present today, although it's a present that might come with a sting in the tail. I'm going to try a brand new puzzle that came out yesterday by the terrifying IcyFruit. It's called Perfectly Balanced. IcyFruit, as some of you may know, is responsible for the 3.5 hour solve that I did a couple of weeks ago on the channel of one of the hardest, the hardest puzzle that I've ever tried on the channel. It was called Taiga, and it was brutal. Now this one, the reason I'm attempting this today without sort of, preparing myself over weeks of working up to it, is that it's only got 4 stars out of 5 for difficulty. So I'm hoping it might be approachable. I snipped some comments on Logic Masters. Let's have a look at those. So, I mean, the problem is Belsita and Mixo are both, I think, actually Silver Screen. Well, all of the 4 people who appear to have solved it are all geniuses. Silver Scree's comment amused me. What a treat, an IcyFruit puzzle with a standard rule set is just what I needed this Friday morning. I got halfway through the breakthrough over coffee and then finished it off doing some sums in the shower glass. That's very beautiful minds, isn't it? That's very clever. Anyway, I'm going to have a go at this. I have left myself probably enough time to make and do another recording later if this one doesn't, if I can't solve it. But IcyFruit is such an incredible constructor that I do look forward to these puzzles, and I want to have a go. So that's what I'm going to do to treat myself on Valentine's Day. Now, I had much excitement yesterday when I did solve a puzzle with the YouTuber Bismuth. We had an absolute blast solving a puzzle. I won't tell you which puzzle yet, but Monday I'm hoping. I have to send it to Bismuth first to check that he's okay with the with how it looks, but I think he will be. So my plan is to release that on Monday, and it is, well, I'm hoping it'll be the start of a new series where I get to solve with some YouTubers that you guys may all be familiar with. Because I mean, I really enjoyed it. I think Bismuth really enjoyed it. So what's not to like? Anyway, that hopefully will come on Monday. There's also a crossword video that I recorded this morning. That's on the channel now. Another Times crossword from a Friday, which is normally the hardest day of the week. A bit of Brian Bilston poetry reading in that video as well. I'll try and remember to put a link on the screen. What else? Oh, I tell you what we should do. What we ought to do, because it's incumbent upon us, is to do a catch-up on Patreon. Let's see if we reached 1,000 overnight. So this is currently our competition, which is running for basically another week until the 20th. The Paint by Numbers Institute have made this great Sudoku hunt called Are You My Mama? And let's do the refresh, reload. Where were we? 97. Oh yeah, we blow. Look at that. All the numbers are now over 1,000, apart from the sample puzzle at the start. That is absolutely fantastic. This is just absolutely fantastic. So the prize, well, if you're one of the 1,000, you'll be you might be offered a chance. We pick a name out of a hat, and then that person will be offered the chance to make a Sudoku video that might appear on the channel. So look out for that in due course. Now, let's do Valentine's Day announcements. Let's have a look. Harry, your girlfriend Emma wrote to us asking me to wish you, from her, I think, a happy Valentine's Day. Apparently you watch every night, and sometimes you can't sleep because the puzzles are too interesting. I totally get where you're coming from, Harry, and well, not many happy returns, but I hope you have a great day today. Obviously, I hope there's some cake involved. Next, I think this is a birthday actually. Sarah over in Oregon. Your sister Audrey wrote to us. I gather you've got snow there at the moment. Thankfully I don't have snow here, but I'm very pleased to hear that you converted Audrey to liking the channel, and now the two of you watch together. And I gather your birthday party today is going to involve pizza and chocolate cake. What's not to like about that? So Sarah, many happy returns. I hope you have a great day today. replete with, well, with what sounds like great food and perhaps a snowball fight. And then I've got to thank Sally, who, while searching for a Valentine's Day card for her husband, made a sort of mock-up of a Valentine's card. I'm not sure if that is meant to be me. I think it is sort of, but nobody puts 3 in the corner. Happy Valentine's Day, you'll have the time of your life. Nobody puts, indeed, Patrick Swayze looking rather more buff than I do. But Sally, thank you very much. And Sally, to answer your question, I do not know what time Mark and I are doing our live sort of crossword episode of Cracking the Cryptic on that day in March at Magdalen College. It'll be great to see you there. If I was to guess, I would say we'll be later in the day rather than earlier, but I have not been told yet, so I can't answer the question definitively, I'm afraid. With all that said and done, let's have a look at the rules to Perfectly Balanced by IcyFruit. The rules are really short, and these are those. We've got normal Sudoku rules apply. In fact, I get given digits, which is weird. So we've got to put the digits 1 to 9 once each in every row, every column, and every 3x3 box. And then it says box borders divide blue lines into sections with the same sum. So this is region sum line. So what that means is that those 2 digits there, you can see they're the only occurrence of the blue line. The blue line sort of cuts into box 2, which is this box, spends a couple of cells and then moves out again. So if we divide this line into segments like that, each of these segments has the same sum. So say that's 10. There might be a reason it can't be 10. Don't worry about that, but that would be 10. The oranges would sum to 10, and the reds would sum to 10. That's how it works. And then there's only one more rule. An arrow points to the smaller of its adjacent digits. So in this domino here, that digit is bigger than that one. I mean, it's just an inequality sign, basically. And that's all. That is all the rules. Do have a go. The way to play is to click the link under the video as usual. But now I get to play. Let's get cracking. Now, so what I tend to do with region sum lines, those 2 digits are the same, aren't they? But obviously, I mean, imagine this was 5. Then obviously for that to have the same sum, this would also have to be a 5. And that 5 would go down here somewhere by Sudoku. Maverick's about to fly over. It is a nice day here. It's actually, it almost feels like spring could be in the air. Those 2 are the same as those 2. What I tend to do with region sum lines is to try and look for big disparities in the length of the line. But here I'm not seeing much at all. In fact, that is weird. That is immediately weird. I'm not sure if what I'm about to say is correct, but I haven't found an example yet of a segment having all the segments along all the lines, I think, are the same length. Like those 3 are matched by 3 there. This line here has 3, 3, 3, 3, 3. 3, 3, 3. Okay, so it's obviously not. So normally with region sum lines, what you can do is you can play off the fact, for example, if you had a 1-cell segment versus a 3-cell segment, then you know the 1-cell segment must add up to at least 6, because the minimum the 3-cell segment could contain would be 1, 2, and 3. But here that is not the game in town, because all the segments are the same length. So it's got to be something, I want to say something geometric then. Because I mean, there's nothing else you can do. It's got to be some geometric trick, because it can't be based off the size of the numbers, is what I'm going to say, because you can't differentiate a 3-cell, and a 3-cell. I mean, I suppose you could say fatuous things like this segment doesn't add to 24, because then that one would also have to add to 24, and there would be too many 7s, 8s and 9s in the column. But that is not going to be how we solve the puzzle. Yeah, I mean, yeah, you can do things like, you can say those 3 digits are the same. Well, no, let's be clear. They're not the same, but they sum to the same as those 3 digits, I think. How am I seeing that? Let's just colour that in for a second. Obviously, each of these green segments sums to the same thing. So let's make that one orange. So that's orange, that's orange. In fact, I might as well do all of them. That's orange, that's orange, that's orange. But what I was looking at was the fact that this box, I mean, let's talk about the Sudoku secret. It's not really necessary to talk about the secret, but I will, just because it's something I like to share with only my favourite people. If you're still watching this video, you're definitely one of my favourite people. All the digits in any Sudoku box sum to 45, and that's because any Sudoku box correctly completed will contain one each of the digits 1 to 9, and that's what you get if you sum those digits. So this box sums to 45, but we know it's got a green segment in it, we know it's got an orange segment in it, so these 3 add to the difference between 45 minus green minus orange. Let's make that, these are the purple. So you can see that the same mathematics must be true for box 5. This must be purple. It doesn't have to be the same digits as this, but it has to have the same sum. In fact, that is interesting, because let's change from box logic to row logic, because row 7 has an orange strip and a green strip in it, just as this box had an orange and a green strip. So that is also purple. So purple cannot be 1, 2, 3 now. Or, oh, it could never be 1, 2, 3. Sorry, purple can't be. It can't be a uniquely high total. Imagine this was 24. So 7, 8, 9. That would be 7, 8, 9, and that would be 7, 8, 9, and we'd have 4 instances of the same digit in column 5. Sorry, that digit would be 7, 8, 9, and those 3 would be 7, 8, 9. So there needs to be at least 2 ways of making the total. Okay, so hang on, that one is also... So, hang on. So if that adds up to purple, and it does, by row 7 logic, then by this little line, that adds up to purple. But now that, I think, has to add up to orange, doesn't it? Because we know that a complete box of Sudoku consists of a purple stripe, a green stripe, and an orange stripe. So those add up to orange. But that doesn't quite map to this little line here, which has only got 2 cell segments on it. Okay, but does that mean that's got to be green for some reason? It just feels like you can do Sudoku, but that might be absolute nonsense. I mean, obviously, whatever that let's give that stripe a different colour. Whatever that stripe is, it's the same sum as that, but it doesn't have to be the same digits as that. So, I don't know then. But wait, no, hang on. Right. I know that. Okay, I know those 3. The sum of those 3 is the same as the sum of those 3. yeah, there's some weirdity going on here, isn't there? It's something like, I think there's going to be roping down here. Right. What I'm seeing there is these 3 digits. Let's use a new colour, red maybe. Those 3 digits. Well, look at box 8. We know that purple plus yellow plus some number is equal to 45. But from this row, we know purple plus yellow plus this must be the same number as that, mustn't it? So these are like, yeah, oh, bingo, right. Forget about roping. What I've now proved is that orange is purple. I think. Because look at this. Well, it's just obvious, isn't it? Those digits have the same sum as those digits. I'm not saying they're the same digits, I'm just saying they have the same sum, because that's what my colours are meaning. And that means that the extra digits in box 8 and the extra digits in box 9 must have the same total to get us overall to 45 in that box and 45 in that box. So purple is the same as orange. So orange I'm going to turn into purple. Oh, now. What on earth does that mean? I mean, that feels like it's done something, doesn't it? So now... So what we're saying now... Okay, so now we're saying... sorry, I'm trying... well, yeah, yes. Although that's weird. Hang on. Sorry, I'm seeing all sorts of relationships here, and I'm not sure which one of them is meaning anything. Okay, what we've established now is that a box of Sudoku is made up of 2 purples, 2 purple stripes, like that one and that one, and a green. So this box is 2 purple stripes and a green. So, okay, so green is odd. The sum of green is odd. How do we know that? We know that because the box adds up to 45, and we know that stripe adds up to something. This stripe adds up to something, so that's 2 something. In other words, the sum of those is even. So green must be an odd total. Now, the other thing I'm seeing here, although this is going to get very horrible to pencil mark, is we've established that the number 45 is 2 strings of purple plus green. Look at column 4. That's 1 string of a purple, so this has a sum of purple, that has a sum of green. So those 3 have to be like a purple sum. I'm going to use the line tool. Oh, that's a terrible choice of colour. Hang on, maybe... Do I want to get rid of this? Does this... What I'm wondering is if that... Well, my first thought was that something here is giving me roping. So do I know that these are green somehow? Or is that... I know that those have the same sum. Actually, why couldn't they be green? I mean, they're just... No, that's just a medley of digits where we know those add up to those. So if that's x, that's y. X plus y. No, okay, sorry, I don't think... Well, okay, here's something different then. A column of Sudoku in this puzzle is made up of double purple plus green, so those 3 are a green set. They add up to green. So these add up to green. These add up to purple. These add up to purple. Yeah, this is weird. Just let me take out this colouring for a moment because I want to just show you something. This column, those add up to purple, don't they? By logic. This column 5, has a green stripe and a purple stripe. So those three are some sort of, they sum to purple is all I'm saying. And these three sum to green because that column is made up of 2 purple stripes and therefore 1 green stripe. So, but like, so in box, that's a oh, hang on. That's I think I've chosen the wrong. I can't see the purple against the purple stripe. No, that's so rotten. Oh, but if I change now, the way my brain works is it's now sort of internalized that it's 2 purples plus green equals 45. So if I was thinking of reversing the colours, but I think I'll just leave that one in. I think I can remember that this is purple and this is purple. This is green. Yeah, so, I mean, what that does mean... I mean, this is a slightly weird thing, but let me just mention it. I know they add up to purple. I know that adds up to purple, and I know that adds up to purple. So there's a sort of set thing going on, isn't there? What we're saying is that those 6 cells add up to 2 purple. Those 3 cells, oh, it's a terrible choice of colour. Those 3 cells add up to purple. These are common. So the difference between yellow and sort of indigo was 1 set of purple. So if I remove the common digits between indigo and yellow, the difference is still 1 set of purple. So the yellow digits are equal to this digit plus purple. But that is itself. No, but that's a purple digit. Oh god, this is don't know. I don't know what that means. Sorry. I think that's going crazy. Right, let's not do that. Okay, so maybe we've got to look at the minimum value of purple. Purple has to be... This is interesting, this little domino here. Because that can't have a single sum, can it? What I mean by single sum is imagine this was a 1-2 pair. If it's a 1-2 pair, then each segment on this line sums to 3. But that would mean this was a 1-2 pair. And this digit shouldn't be able to exist because it would see a 1-2 pair there, and it would itself need to be a 1 or a 2. So then this sums to at least 5, because 4 wouldn't work. That's only achievable with a 1-3 pair. So this adds up to at least 5, and at most, but without 9. No, that doesn't work. Well, you could have 15 here, couldn't you, with a 7-8 pair, and then that could be 6-9, and that could be 7-8. Bobbins. Okay, so purple is at least... No, purple is a maximum of 24. No, purple's not 20. Right, no. Purple, 2 purple plus green. Hang on, green includes a 6 down here. So the minimum value of green is 9 if we put 1 and 2 here. So green is a minimum of 9, which would make purple, 45 minus 9 is 36. So purple is a maximum of 36 divided by 2 is 18. maximum. So purple is a maximum of 18. And what did we say? These had to be at least 5. So, oh, that's restricted then, is it? No, hang on. I think I'm confusing myself. I'm going to have to do this again. Okay, I said this could be 9. If it's 9, purple is 18. So I think purple has a... Let's just put it over here as an 8 memoir. Purple could be 18 maximum. But purple minimum is... If this is... That was 5, wasn't it? Because it couldn't be... So 14 is the minimum. So purple is some number between 14 and 18. Which means green... If purple is 14, that's 28 for 2 lots of purple, so green would be 17. Oh, I know what it'll be. They're all going to be 15. Oh, right. Yeah, suddenly look, if green was 15, then these would be halving 30, which is 15, 15, 15. Yeah, 15. We know green is always odd, don't we? And it can be as low as 9. So yeah, okay, so we go so the possible values of green are 17, 15, 13, 11, 9, and that corresponds to each of the values 14, 15, 16, 17 and 18 for the values of purple. So that would be a 9 there. These are the extreme values. So okay, and we've got what have we got going on here? We know those are the same. No, we don't know they're the same. We just know that they are the same value as those. So, and we know those are the same value as those. My brain is telling me that this is all roped down here, but I'm not sure that's actually logical. But I think I'm confusing myself. I'm thinking, you know, if these add up to 20, then those have... It's true to say those have to add up to 20 as well, but they don't have to be the same composition of digits, which is, I think, why my brain keeps saying, oh, these are green, but I think that's just not right, because I want to put those digits there. No, hang on. Right. It is roped. But I don't think I know how. Actually, I'm not sure now. No, I think it is. No, I think it is. Okay, I'm going to restore... I'm just going to quickly restore my colouring down here. Oh, terrible choice of colour. Let's do blue and orange. Right. That all these are saying is the sum of orange is the same, the sum of indigo is the same. Right, let's make that, let's make these A, B and C. Now, what I was thinking is, if these are A, B and C, where do we put A, B and C in this box? Now, in order for us, well, there would be roping. If none of these were A, B and C, let's make those X, Y and Z. Right, then we've clearly got roping in the sense that A, B and C have to now go here in these three, and A, B and C would be here. So we get ABC, 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 and then this XYZ would have to go there, and then it would have to go there. So we get total roping. Actually looks a bit weird, but anyway, so that causes roping. What would also cause roping, just different roping, would be this. If this is ABC, and this has all three of the digits A, B and C, then clearly this is ABC. And then again we've got roping, because those digits, whatever they were, would have to go there, would then by Sudoku have to go there. So we'd again get roping. But here is a small point. Okay, well obviously the counter argument to that is to say, well, hang on, you've just looked at two extreme positions where this is either entirely consistent with this or entirely inconsistent with this. What if, for example, there was only one of A, B and C here? Let's put A there. Well, the point then is, where are B and C in this box? And the answer is by Sudoku, they're there, and therefore, I suppose another way of thinking about it is, where are B and C in row 7? They're over here, aren't they? But that's it. That causes roping. In fact, this is just impossible. Because if this has got B and C on it, but it adds up to purple as a string, and we know that purple consists of B plus C plus A, that digit should be A. And couldn't be, because we've tried to put A there. But there would definitely be roping. And that, I feel like that argument must work. If we make this B and C instead, then obviously you need to put A there. So you can't have two digits here, because then the third digit would always have to be A. And if you only have one digit here, well then that one has to be ABC. So although we don't know, in fact we really don't know, where the roping happens in the bottom three rows, there is roping. Because A, B and C is either here or here. Sorry, I realised I've stopped talking. I don't know what that means. I'm sure it means something. So there is, okay, well there is roping. Just put A, B and C in then. A, B and C. Well, I can't though. I don't know where they go. I don't know whether they go there. And then there. Or they go there. And then there. And then obviously these would have the same sum as A, B and C. So they would be purple in effect. Oh, okay. So if I see. So one of these is going to be a purple stripe, and the other one is going to, therefore, in this box going to be a green stripe, which is this one. So actually now these colours are purple and green. But I don't think I know. Well, hang on, I know that's green. Hang on, this is really confusing. Oh. So, oh, good grief. IcyFruit, that's sick. That is brilliant. Okay, I think I can do it. I think I can do it, can't I? Yeah, I don't think. Okay, so what we've now established is that purple. Well, let's use. All right, what we're going to do. We've got to remember this stripe and this stripe are the same total. This stripe are the same total, and we know we're roping. So, what I want to consider first, because it's wrong, is whether this ABC don't go up here, but they go there. So we know now that this is a purple string, don't we? And we know therefore that this would be A, B, and C. And we know that 2 purples plus green add up to the world. And so this would be purple. So this is the pattern we'd have. This does not work because we know that the sum of these digits is the same as the sum of these digits. But we know the sum of those 2 digits is the same as the sum of those 2 digits. So that effectively they cancel out, and that digit would have to be the same as that digit. I hope that's clear. I mean, imagine this is that's x. The sum of those 2 is x. X plus 6. Over here, we know that's x. So what's that got to be, given that we know that both sides sum to x plus 6? It would have to be 6. It doesn't work. So what this is doing is it's telling us the direction of the roping. It's telling us that this is ABC, which means by Sudoku that is ABC, which means it's purple, which means that's green, which means that's green, which means that's purple. Okay, and therefore, that is green and that is green. So those 2 add up to the same as those 2, which add up to the same as those 2. Yes, right. So now, oh no, am I wrong? No, I must be. Hang on. I want to say these can't have a single digit constitution now. What I'm thinking is, no, I mean it's very, actually I don't need to use this. Right. One of the options that I've got listed out here, in fact I might put them all in. I know that, which one was this side? This side was the purple, yeah, because 9 was made up when we put 1 and 2 here. That's definitely wrong. Because if green adds up to 9, this is a 1-2 pair. But this is also adding up to 9, so this would be a 1-2 pair, and we'd have too many of the same digit in box 8. So this one is wrong. That cannot be right. Now remember, we're always looking at an odd digit for the green total. So I'm just going to put the options down here, if you forgive me. 15, 13. I can't do 11. I'll have to mess about. I'll do it like that. And these digits are therefore 15, which is, I think, what we're going to end up with, 16, 17. So purple is one of these. And how does that work then? So if this was all 15, wouldn't I get into a trouble here again? Those would add up to 9. Those, yeah, that doesn't work. 15 doesn't work. Because if we're saying purple and green are the same number, but we're also saying that those are the same number, then that would be a 6 in the corner, so we can get rid of another one. So now I've only got 3 possibilities left. I've either got 17, 13, or 11. 11 would put great pressure on the world. If this is 11, they would add up to 5, they would add up to 5, they would add up to 5. But purple would be... no, that's too big. Wow. Okay, we can get rid of 11 because of the distinction between the two values. So what we're saying is that if we use 11 as the value of green, the value of purple is 17 by maths. Let's just double check it's right. But because 45 is the total for a box, 11 for the green, well, that gets us down to 34. So 34 divided by 2, because there's 2 strips of purple, is 17. So this is how it would break down. But look here. If this adds up to 5, which is what we would have if green was 11, that would be 5. This would be 5. But we have to get to 17 for that string, so that would need to be a 12. We can't write 12 into Sudoku, so that doesn't work. Right, let's try this one. 13. 13 for... These would add up to 7. These would add up to 7. Oh, and that would be 9, would it? 7, 9 to get to 16. That's okay, I think. Actually, that might not work. Let me just have a think about this one, because I'm worried that I've made some error here and nothing's going to work. If green is 17, that's 11. So that's 11. So that's 3. That's 3 in the corner. 3 in the corner. These would all be 11. That would be 11. But if this is 13. 13, I think, is a problem with roping, but I might be wrong about this, because what I'm thinking is that would be 9, so that doesn't... Okay, so it's not 3, so I can't rule out everything. Yeah, but if... Okay, if we're in this world, let's just really focus on this. If we're in this world, what we're saying is that green adds up to 13. Now, that means this domino adds up to 7, and this domino adds up to 7. But the 1/6 variation of this is gone. So one of these would be a 2/5 variation, and one of them would be a 3/4 variation. And we don't know which way round that would go. But what I'm going to say is that whatever this was, 2/5 or 3/4, this domino adds up to 7 as well, because it's the same total as this, and it can't be 1/6. So I think those 2 digits would be the identical digits to those 2 digits, and that cannot be true, because we've got roping. So because one of these digits needs to be A, B or C, and it can't be. So I think this one is knocked out, and this one is the correct one. So we're in 14 for purple and 17 for green, which means that these add up to 11, these add up to 11, these add up to 11, and our first digit is that. And that's 3 in the corner. That's 3 in the spotlight, losing its religion. And now each of these stubby things adds up to 11, without being 3, 8 or 5, 6. So this is 4, 7 and 2, 9 in some order. And that's not 9, so that's not 2. And we have to... Okay, and whatever this is, which also adds up to 11, is not that. So this is so beautiful. So this domino, which adds up to 11, is not 5, 6. It's not able to be any of these. Because if it was one of these, if it was this, roping would fail. And if it's these, it's in the same box. So this has to be 3, 8, I think. Well, if that, hang on, and if that's true, which I think it feels right, doesn't it? Because the ways of getting to 9 in a domino are 2, 9, 3, 8, 4, 7, 5, 6, and we've ruled out all but 3, 8. But if this is 3, 8, that one can't be the 3, because that would go there, or it would be an ABC digit. So that must be an 8. This must be a 3. Yeah, that's just roping. That's just roping coming through, isn't it? What I could have done is labelled these 3 here, because we know we've got roping. Oh, in fact, that's what I should do. So these are 6. These are 6. There's definitely an 8 down here. Okay, sorry, that was probably totally inept. So 9 is not here, so 9 is in one of those. But I've got green here. Do I know? I haven't, we never proved roping in columns 4, 5 and 6, did we? Even though that's green. I know that's green because I knew these were 2 purple. Yeah, I knew those were 2 purple. So I know that adds up to green, but I don't know it's necessarily the same as the other green digits. Although, hang about. Isn't it the same point again? Those add up to purple. So where do I put them? I either put them, if I put, no, it's the same. There is roping. I've got a horrible feeling this is totally obvious, and I'm struggling to see it because I keep doing it by algebra. Okay, I mean, the way I'm seeing this is I'm looking at column 5. I know I've got green. I know I've got purple. So if you remember before, we know those do add up to purple. These ones here. Let's use it. I don't want to use a different colour, but they add up to purple because we know that any column is made up of 2 lots of purple plus a green. Now, let's just make these. I'm just going to go over my. Let's make this GHI. Now, we know these 3, GH and I, add up to purple. Where are we going to put them in this box? Now, if we put all 3 here, I've got roping in the column clearly. GHI, that's going to be GHI, and that causes roping. If I put none of them here, they go there, and then I'd have, well, that's not going to work, but I mean, it would also cause roping. And if I put one of them here, say, I can't put 2 of them here because then the third one would be, by mathematics, would be the third one of here. So I could put one of them here, but then I have to put 2 of them there, and then by Sudoku, 2 of them will be in this stretch, which also adds up to purple, so I will still get roping. It's just this will be GHI rather than this being GHI. So there is roping in the columns as well. But if I know that's green, and I do, and I know that green does not equal purple, and I know there's roping, then I know that's 836, don't I? I know that must be 368. And I know 14 is the total. Oh! Hang on. Let's just move this down here, because 14 is the total for purple. So this adds up to 5. That's right, and it doesn't involve 3. That's a 1-4 pair. So this is a 2-3 pair because it's got to add up to 5 and not use 1 and 4. This is a 1-4 pair. This line now hasn't got 1, 2, 3, 4 or 5 on it. So 6, 7, 8s and 9s. And So it's at least 21. So those are at least 21. Ah, it's not 23 or 24. Because if this, say it was 23, there's only one way to make 23 in 3 numbers, and that's 689, and then that digit would be from 689 as well, and you'd have too many digits from the same collection. So this either adds up to 21 or 22. And if it's 22, it's 679. And that doesn't work either. Yeah, this adds up to 21 exactly. Because let's say it didn't, and we said, okay, well 22 is possible. If that's 22, 679 is the only way we can do it. And now because of this 5 here, that 589 has been ruled out as an option to make that work. So this is also 679, and now I've still got exactly the same problem I'd have had if we were trying to hit the jackpot and make this sort of 789 or something. You know, if this is 789, that would be 789 to get to 24 on this string. So this is 21. It is 678. So this is 21 without using, well, that digit. What's this digit? Oh, it could be a 4, could it? I'm not sure. I was thinking this was going to be 9, but I think it might be able to be 4 with an 8-9 pair. Unless for some reason there's roping down here, which would be quite funny. In fact, no, this is the way to do this. Where's 9 in this box? These given digits are beautiful, aren't they? They're sort of weird, what they're doing. Right, this can't be 4 now, because that would require an 8-9 pair. And 9 can't go there anymore by Sudoku. So this is 9, I think. And these two squares add up to 12. And they are 4, 8. And the reason they're 4, 8 is they're not 5, 7, and they're not 3, 9. So there we go. And now that 4 is done. 4, 1, 4, 1. Okay, this now is not 4 or 9. And remember, this adds up to 11. So this is 4 or 9. And it's not 4, so that's 9. And that's 2, which means this is 4, 7. And we know the order. So that's 4, that's 7. Now, we did have roping down here, didn't we? We did definitely have roping. I'm sure we did. So 4, 6, 7 goes in there and there by dint of roping. 3, 2, 9. Well, we know that's got to be the 2, 9. So this is 2, 3, 9. That's not 2. And A, B, and C now. We're going to get A, B, and C sort of by leftovers. 1, 5, 8, I think. And that's not... So this, hang on, this is all done, isn't it? So this is 1, this is 5, this is 9, this is 2. This is not 4. This is not 8 or 1. That's 5. This 2 is doing work. That's 2. That's 3. 6 or 7 into that square. What about this column, though? That's a 4 by Sudoku. Can't be 6 or 7 because of this. That's a 1. 1, 8. What's this digit? I know I can do it. 2. Why have I got a 1 in that cell as a corner pencil mark? What gave me that right? Why? I don't remember ever looking at this cell. Is that bobbins? Is that just a sort of anachronism? I'm not sure. Let's look at these digits. 1, 3, 6, 7. And there is an inequality at work, so that's definitely not 7. That's definitely not 1. 2 over here. So there's a... nearly. So there's a 2 in one of those. But presumably... yeah. Okay, remember we worked out this vertical roping in columns 4, 5, 6. Well, this 194 now is going here, isn't it? So that is 194. So this must be the position of the 2. 2 is paired up with 5 and 7. And these squares are 2, 5, 7 as well. That's not 2. That's not 5. Bobbins. Okay, so we're nearly there. Little point, that digit can't be 6. Because if it's 6, that would be 7, and this square would have no way of being filled. So this is very small. If it's 3, that is 6 or 7. This would have to be 1. I mean, those... No, that's nonsense. Okay. We've got another inequality at work over here. So that's not 7. That's not 4. And what did we... I should know by now what the total of purple is. 14. Okay, so that's 14, and that's 14 without using 2. And no, it doesn't mean it has to have 1. 3, 4, 5 is only 12. So, this is a brilliant puzzle, though, isn't it? It's. I mean, it's IcyFruit all over. It's so. I mean, it's so original. It's so original to do region sum lines without using the same length segment. Okay, so that one adds up to the same as that one. But those 3 add up to the same as those 2, and those 2 are the same. So that means those 2 add up to the same as those 2, I think. That means... Oh, nearly. Oh, that's... Well, no, this is good. This is still... That's really interesting. Okay, let me just explain what I was doing there. So what I did was, I said, okay, those 3 add up to the same as those 3. I don't know if they're the same digits, but they definitely have the same sum. So mathematically, that is true. Those 2 are just the same digit. So they have the same sum. So mathematically, we can express the total of box 3 as purple plus yellow plus red plus those 2. I'll make those orange. Oh, terrible. Blue. Now, in this box, this whole box, which is obviously has the same sum as that whole box, also has 3 yellows. It also has red. It also has 3 purples. So those 2 are the equivalent blue in box 6. In other words, those 2 blues sum to the same as those 2 blues. Now, why is that beautiful? Well, I think we think about the digit 2. Because if 2 was blue here, let's say it was there, then mathematically these 2 digits would be the same number, and that cannot be true. So 2 in this box is not there, it's not there, it's not in blue, it's there. It's in one of those 2. Which means I get 2 down here. Oh, nearly. Oh my goodness me. Well, okay, so the thought that I then had is, okay, these digits add up to 14, don't they? Now including a 2. So the other 2 digits add up to 12, and they don't involve a 3 and a 9, because that square would die. So it's either 257, whoops, 257 or 248, and that's definitely not 2, and that's definitely not 4, and that's definitely not 4, and that's definitely not 5. Oh, that can't be 3. There's probably more Sudoku to do here. Yeah. Where's 1 and 9 in this row? Boom is where they go. So this digit is the same as that digit. That's 1 or 9. So there's a 1-9 pair here. So that digit isn't 1 anymore. In fact, there's 9. 9 is there. That would be the easier way of doing it. So that digit is 1. That digit is 1. That digit is 9. So, okay, so that's a 1 in the bottom row. This is a 5-8 pair. 9 is now a digit in yellow. But that doesn't mean you have to have a 9 here, at least I don't think it does. Red. Oh, nearly. I nearly had an intelligent thought then, and then it didn't work, so I won't even tell you what it was. Ah, no, that doesn't work. What about this row? Can we? We can get rid of 1 from a couple of places. Is Sudoku somehow resolved? Ah, yeah. So that's a 4. 3, 5, 6, 3, 5, 6, 7, 8. That's horrible pencil mark. Alright, what about this 1-9 pair? Is that somehow resolved? No. It would be nice to get, if I could get 1 digit on here. Oh, right. Here we go. 1 and 2 are now off this segment, so it must have 3 on it. Because if it didn't, its minimum sum would be 4 plus 5 plus 6, which is 15. And we know this adds up to 14 because it's a purple segment. So this is 3 plus 2 digits that add to 11, which are either 5, 6 or 4, 7, because they can't be 2, 9 or 3, 8. So I'm not sure. It would be very handy to know what this is, wouldn't it? If this was 2, it can only be 2, 4, 8 if the 4 is at the very top. So it would go 4, 2, 8, 4, 4 in one of those 2 squares. What did we say the blue? The blue added up to the same as this. Maybe that digit is where we look then. Okay, those 2 digits sum to the same as those 2 digits, but this can't be 1, 2 or 3 because of our pencil marks. It can't be 4. Because if this is 4, these add up to 6, but they can't do that because 1 and 2 are not available. It's not 5, so it is at least 6. So it's 6, 7, 8. It's not 9 because I've got a 9 here. 6, 7 or 8. If it was... Oh, nearly. I was just going to say if it was 6 it doesn't work, but it might do. 2, 6 is 8, so these have to add up to 8. And they couldn't use 1 and 2, so they would be 3, 5, which would make this 2, 4, 8. That would be 7. Actually, I think that might work. And hang on, I can't quite work out what that digit would be. I think that would be the balancing digit in the column. So if that's 6, that's 7, that's 3, 5. 4 hasn't appeared in the column. It would go there. That looks good, doesn't it? Okay. Okay, so how do we do this then? I think it's to do with blue. So the total for this is 8, 9 or 10. And Ooh, nearly. Wait a moment. Oh, I see. No, it's much simpler. It's much simpler. Sorry, I hadn't spotted this. Okay, where's 9 in this box? Now, the answer is I haven't got a clue, but I think it is in yellow. Because if 9 was... Remember the purples add to 14. So if I put 9 on here, the other 2 digits add up to 5, including a 3, so I'd need a 2 there. So 9, in fact 9 is in that domino. That gets me this digit. So that's 3, that's 9. So... Oh, bother. Does that not do anything? So, oh, hang on. So those 2 digits add up to the 2 digits here that are not 9. No, I was about to say, oh, hang on, where? No. Everything I'm trying, it just doesn't work. Okay, I'm going to go back to the reason I started to think about 9. It was because I was looking at this domino. Because, why was I looking at this domino? Well, what I was thinking is that we've established a mathematical sort of principle up here, haven't we? That a whole box of the Sudoku is equal to purple plus yellow plus red plus blue. But that a box of a Sudoku must be the same as a column of a Sudoku. And this column has purple plus yellow, just as this box did. So these digits must be red plus blue. And indeed, look, there is a red, that one. So in fact, those 2 digits add up to the same as those 2 digits. They're not the same digits necessarily, but they, in fact, they almost certainly are definitely different, but they do add to the same. And they also, don't forget, add to the same as those 2 digits. Because blue adds up to those 2 digits. So 8 is the minimum total for this. So this can't be 4. That would not be possible by mathematics. So that's not 4. That's 4. Which, is that not going to do anything? So 9 or 10 is the total here. So, so 6 disappears from this one, because that would be 8, and that's not possible to make with those digits. So we're now at 9 or 10. And if it's 9, that's no. That's beautiful. That's absolutely beautiful. Right. If this is 9, by the mathematics of this column, those added up to 9. So 2, 7, that has to be a 6 to make this add up to 9. And that's a 7, and we get 2 7s in the column. So that is 8. That is 8. That's 5. Now we're in business, because 8 accompanies 2 on this line that adds up to 14. So it's 4, 2, 8. And that's an 8. In fact, that's a 4, that's a 2 I'm seeing as well. So 2 has to be here. This is a 6 by Sudoku. That is a 7 by Sudoku. So 5, 7. That must do more things than that. This adds up to 10. So this adds up to 10. So that's 7. And this is 6. And this adds up to 10. Thank God that works. 3, 7. I was thinking there's no way it works, but it does work. So that's 3, that's 8, that's 8, that's 6. 6 must go here. 5 must go here. So this adds up to 20. So this adds up to 20. We need 2 digits that add to 11. So it's, oh, these are the same then. 5, 6, 9 is how that's working. That's not 9. That's not 5. And these digits add up to 14, isn't it? So we need 11. So it's 3, 4, 7. Yeah, so the 4 must go here. And this is a 3, 7 pair. And that 4 needs to work some... no, it's not working magic, is it? Oh dear. This can't be broken, can it? It's been so, oh no, here we go. It's been so beautiful to this point. I found it very hard to accept that this isn't correct, because every single deduction has been so glorious. Where's 7 in this row? That's a weird question, but it seems to be answered. It's got to be there, I think. 7, 3, 3, 6, 7. Yeah, 6, 3, 1, 1, 9, 6, 5, 9, 5, 7, boom. What a puzzle that is. That is stunning. It was rather, well, it was easier than Taiga. It was several hours easier. Oh, I haven't finished. But it was glorious. That is so original. It must be right. Oh, as all things should be. Perfectly balanced, as all things should be. Well, that's absolutely... Hang on, it only came out yesterday on Logic Masters. Apparently it's been in existence for 10.7 days. 22 people have solved it. Well, those 22 are... Well, I think they will join with me and say... IcyFruit is one heck of a Sudoku maker, one heck of a puzzle maker, just incredible again. Such an original idea. And okay, what I'm a bit worried about is I fear, my brain was telling me that this bottom was roped really early on, and I have a horrible feeling that I could have seen that very cleanly, other than by doing algebra. And if I could, I'm sorry. I didn't. I could only see it really by thinking about this being ABC. It's a really interesting puzzle, just a fascinating puzzle again, from a genius. Let me know in the comments how you got on. I enjoy the comments, especially when they're kind, and we'll be back later with another edition of Cracking the Cryptic.